Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video, we learn about differentiation using first principle and also the introduction to differentiation. Right, before that, let's go through first what we learn in the whole chapter of differentiation. So the first one in this video, it is about derivative of the function using first principle. And then later in the next video, we learn about the rules of differentiation, and then the implicit differentiation, and after that, differentiation of exponential, log, and also trigo function, and last but not least, the parametric differentiation. So this is differentiation using first principle. So actually, we linking together with the previous chapter. Remember, the previous chapter we learned about limits and continuity. So using first principle here, actually we're using a formula that related to limits. That is limit when h approach 0 when f of x plus h minus fx over h, right? So later we'll also use the below formula when we want to find the specific values of differentiation at certain point. Okay, what is dx? Remember in secondary school, when we learn about dx, we always relate this one with differentiation. So actually, dx represent a gradient of function, and the one that you always closely associate with differentiation is this one. So in correct way, dx represents derivative of y with respect to x. Means that if y in terms of x, so when we differentiate, it will become dy over dx. But remember, if we have a different variable, the notation also will be different. Such as in parametric differentiation, we have x in terms of t, like this one. So when we differentiate, we cannot use the notation dy dx anymore, because the left hand side is s and right hand side is in terms of t. So notation should be derivative of x with respect to t, that is dx dt in this case. Okay, so this is what we call differentiation. And also apart from notation dy dx, we also can use f prime. So if the right hand side is in terms of x, so f prime x lah. If in this case, so it can be f prime t lah. Okay, because right hand side in terms of t. And also y prime. Okay, if dy dx, then we can use y prime. So in this case, dx dt, so maybe is x prime lah. But we very seldom use x prime. Usually we use y prime lah to represent dy dx. But this is also this is the notation that you should know. Other than dy dx, okay, f prime and also y prime. So this also represent differentiation sign. Okay, right. So this is introduction, the concept, how on earth we get this formula. Okay, so let's take a look about the concept of gradient. Okay, so focus on this triangle. So in this triangle, the side here is fx, and the above here we have x plus h. Okay, so h is here. So for x, it is x plus fx plus h here minus fx. Okay, so this is the difference for x. And for the left side here, so here we add x plus h and then x. So x plus h minus x, so we can cancel out x. That's why we only have h below here. So this is the concept. How on earth we got this formula? Okay, that is fx plus h minus fx over h. So as h approach 0, right? Okay, you can read this statement. I don't want to discuss in detail about this one. Right. So as I said before, apart from dydf, we can also use f prime. Okay. So f prime is also limit h approach 0. So this formula that we already discussed before. So this is what we call the first principle. Okay. So let's try to solve a few questions regarding using first principle. So the first one, x squared plus 1. So let's see. So use the formula. So f will become f prime. And then don't forget the formula, we have limits here. X plus h minus fx over h. So x plus h means, so the x here we plus h. So x plus h squared plus 1. Okay. So this is x plus h. And then minus, so the back here is fx. Okay. And then over h. And then the square at here we expand. So we got this one. And then after that we can cancel out with the back one. So we will expand here. So we got negative x squared minus x. So we can see we can cancel out x squared, x squared. Okay. Oh, not sorry, not minus x, minus 1. So minus 1 also can cancel out with this one. So we can see we only have sh plus h squared. Remember the method to solve indeterminate form, you have to factorize or multiply with conjugate. So in this case we can factorize h, right? So we factorize h, and then with that we can cancel out the same factor. So after we cancel out the same factor, then we substitute h with 0. Okay, so sub h with 0. So 2x plus 0 means that the answer is 2x. So this is the answer for these questions. So therefore we can conclude that f prime equals to 2. Now for question B, the function given is 1 over x. So we know the notation, remember f prime on the left hand side. So limit fx plus h minus fx over h, and then so 1 over x, so x plus h means that x plus h over here, and then minus 1 over x. Then notice this is a fraction. Okay, so we have to equate denominator. So that's what we do here, equate denominator. So below here, x times x plus h. So here cross multiply x minus x plus h. So then we expand, we can cancel out x. So leaving only negative h, right? If you notice. Okay, so that's what happened. And then you notice that we have actually over h here, or divide by h. So divide by h, since we already have a fraction here, so we move at the front 1 over h in front here. Okay, so that's originally here we bring to the front 1 over h. So here we can focus on the fraction only. Okay, so negative x over x minus h. So then we can cancel out this h. So after we cancel out h, so no more h denominator, right? Then we can simplify and substitute h with 0. So substitute h with 0, we know below that it is x squared. Okay, so the answer is negative 1 over x squared, right? So please take note, this example later on if you come across with a fraction like this. Right, next for question C. So question C, we have third. So substitute into the formula we have here. So here s plus h, this one fx without h. So we notice that we have third here. So for third we have to multiply with conjugate. So conjugate is actually third plus third, right? Because this is minus, so this one is plus. So don't forget below here also we need to multiply with the same conjugate, okay? So that's what happened below here. So see, this is conjugate also below here, right? But this conjugate below here we don't expand. We just focus expand the above one, their conjugate. So we expand. So we notice that we can cancel out x, okay, and also 1, right? So leaving only h. So after that we can also cancel h. So leaving only this one. And then later we want to sub h with 0. So sub h with 0. So we know it is x plus 1 and also x plus 1. So it means that 2 times x plus 1. So that's the answer for question C. Right, next for question D. So here we have combination with a rational plus third. So sub into the formula. So this is what happened. So remember later h here we bring to the front. So it become 1 over h. And then here what we do first? Multiply with conjugate first or equate denominator first? So first we need to equate denominator first, okay? So this is what happened. We equate denominator first. So below we multiply these two thirds. And then above here, so we cross multiply. So x minus 1 minus x plus h minus 1. Then after this, we multiply with conjugate. Okay. So conjugate, what's the conjugate? The conjugate actually represent the above one, not the below. So this is conjugate. So the conjugate for the above here is third plus third. Okay. So remember below here also we need to multiply with the same conjugate. Okay. So this is what happened. So remember, as I said before, we only expand the above one. Okay. Expand the above one. The below one we don't expand. Okay. So expand the above one. So we know we can eliminate the third. So third will cancel out. So x minus 1, x minus 1. X plus h plus 1. So here x plus h plus 1. So notice below here we don't expand. Okay. We just leave it like that. So the above here we can clearly see we can eliminate x and also 1. Because this is negative, negative, positive 1. So leave it only h. So we continue the solution in the next slide. So in the next slide, don't forget we will have negative in front of h. So we can cancel out h with the h in front here. So leave it only below here, right? So below here we just substitute h with 0. So 0, 0. So let's see what happened. So we have third x minus 1, third x minus 1. So means that 2 times third x minus 1. And then x plus 1, also x plus 1. Oh, minus. Minus 1, minus 1, minus 1, minus 1. So actually we have x minus 1 above here square, and then 2 times x minus 1 if I'm not mistaken. So let's see, is it correct or not? if the one I notice here. Yeah, correct. So square here means that we don't have a cert, and then here two times in front of here. So x minus y is actually the same terms, right? So we can simplify the index. So this is power of 1, this is actually power of half. So it will become power of 3 over 2. Okay, so that's the final answer for this question. So if you notice that the solution will become more complicated when it comes to the question D here. So I hope you can take a look very slowly. If you need time, you just pause the video first, and then if you after you understand the step, then you can resume the video and see what's the next step. Okay, so that's the advantage using the video compared to the direct lecture in Google Meet. You can pause the video if you need a little bit time to understand the certain step. Okay, right. Now example 2. Given function f for x plus 2x squared. Find, I think it should be f prime over here. Okay, f prime from first principle, and hence calculate f prime 2 and f prime negative 2. Right. So firstly, we have to do first principles. Remember the formula fx plus h, right, minus fx. Okay. So 4x plus h, 2 times x plus h squared over h. And then we expand. Oh, here they already simplify. So actually this one you will get x squared plus 2sh plus x squared. And then multiply with 2 above in front. We got 2, we got 4 here, and we got 2h squared. And then above here we have 4x plus 4h. So at the end we got to h squared, 4h dengan 4hx. The rest we already cancel out. So this 4x you cancel out here, right? So that's after we simplify, we got this one. So you can try do your own, because in this example we want to focus about to find the solution. Right. So here, as you know, what we'll do here, we factorize h. So we got 4 plus 4x plus 2h. Okay. So h and h below we simplify. So that's why we got this one, right? And then we substitute h with 0. So 0 here. So we got 4 plus 4x as our f prime. Okay. So that's for f prime. And then we want to find f2 and negative 2. So this one very simple. We just substitute the values. So substitute the values. So we got 4 plus 8, and then we got negative 12. And then for f prime negative 2, so substitute with negative 2, and then we got negative 4, right? So very simple. Example 2. Okay, so now we want to use another formula. So this formula is actually derivative at a certain, given certain specific point. So we will use this formula. So instead of x plus h minus fx, so here we have fx minus fa over x minus a. So the previous here over h, right? So now we change a little bit. So here no more h, this time x, and approach a. Good. So let's see how. So there's a note here before we can proceed. That is, the function can be differentiable if the limit exists. Okay, we know limit exists, limit from left and right equal. So in that case, limit exists. But in this case, since we already associated using first principle, that is using limit. So in other words, not only limit exists, but also the function is differentiable or f prime exists at that point. Right. So now I want to explain the two situations here where the function is continuous, but it is not differentiable. Okay. If you look at these two cases, so the first one, the corner here, like a absolute function, the function is defined and the limit is exists, so it is continuous. However, if we check the differentiable, it's not differentiable. Same also here for vertical tangent. Even though it is continuous, but it is not differentiable. So remember these two cases where the function can be not differentiable, even though it is continuous. Right. So show that the function is continuous but not differentiable at x equals to 1. So let's see. First, we know the three conditions for the function to be continuous. The function is defined, right? So when I substitute x equal 1, we got 0, right? And next, check one-sided limit. Limit from left, we got 0 and also 0 from left. Okay, so no problem. So we know the limit exists, and also since the limit and the function has the same value, therefore it is continuous. Okay, so you already know, right? These three steps. So this is step number 2 and this is step number 3. Okay, remember to determine the continuity. Okay, so now look at differentiable or not. So we use one-sided limit from left. Limit, remember, so fx minus fa, okay, over x minus a. So we check here, and then, well, we don't want to show in detail, so maybe you can do on your own in detail about this. So here we got power of 2 over 3, and then 1 over 0 positive. Okay, we substitute the limit, right? X1, okay, 1 minus 1 is 0. So 0, since it is from right, so it will be 0 positive, okay? So 0 positive, it is positive infinity. And then from left, so we substitute, we got 0 negative. So since we notice that left and right negative here, so we got negative infinity, okay? And now since we know that this point positive, this one is negative infinity, so the limit does not exist. So therefore, since the limit does not exist, therefore f is not differentiable at x equals to 1. Okay, so this is how we show the situation where the function is not differentiable. Okay, next we move to the example 4. So remember, we will use this formula, fx minus fa over x minus a. But if you want to use the original formula, limit x plus fx plus h minus fx over h, you got f prime, and then later you substitute the value. So that one also can, okay, like the example 2. But now we want to focus using this formula. So we substitute fx minus f a over x minus a. So fx is 3x squared minus 12. Fa, we sub the values. So x with 2. And then we got x 3x squared minus 12 over x minus 2. Right. So we try to factorize. So after we factorize, actually we got x squared minus 4. So x squared minus 4, we know we can factorize to become x minus 2 and x plus 2. So we know x minus 2 we can cancel out with below here. Right? So when x approach 2, we just substitute the values, and then we got, don't forget we have 3 in front here. Okay. So 2 plus 2, 4, 4 times 3, then we got the answer is 12. Okay. So I hope you understand how to use this formula, fx minus fa over x minus a. And remember, at that certain point like this one, you have to use the method you already learned in chapter 8, that is factorization. Okay, next for question B. So we have third here. So let's see. We substitute the formula fx minus f3, and then we got x plus 1 minus 4 over x minus 3. Okay. So we have third here. So what we do if we had third here? Yes, we have to multiply with conjugate. So that is third x plus 2 plus third 4. So this one we can simplify it to become 2. So this one plus 2 lah. Okay. So remember the below here also multiply with conjugate. Okay. So that's what we do. And then remember, as I said before, we expand the above one only. So leave it below here. Do not expand. Okay. So after we multiply, so 1 minus 4, and then we got x minus 3, right? So x minus 3 we can cancel out. So we got only 1 over third x plus 1 plus 2. Next. So after we got this one, then we can sub the values, right? So 3 plus 1, 4. So sub 4 to 2 plus 2, 4. Okay. So 4 plus 2. So that's why we got the answer is 1 over 4. Next, for question C, 1 over x plus 1 when a equals to 8. So limit x approach 8. So fx minus fa over x minus 8. And then substitute fx. So we got third here. Remember, like the previous questions. So here we have to equate denominator first. After we equate, then we can multiply with conjugate. So we equate first the fraction. So that's what we do. So multiply 3 with x plus 1 below here. So above we cross multiply. So 3 minus x plus 1. Okay. Then after that we multiply with conjugate. So after that we multiply with conjugate. So the conjugate would be, so the conjugate will refer to above here. So the conjugate will be 3 plus x plus 1. So that step we show in the next slide. Okay. So in this slide, okay, as you can see here, and then below here, notice that we already bring down and then put together with the conjugate in one line, the denominator. So we have three terms in the three different factors in the denominator. So we only expand the above one. Below we don't expand. So expand the above. So we got 9 minus in bracket. So we can eliminate the third. So we have x plus 1. So this one we will get 8 minus x, right? So 8 minus x we can factorize, okay, to become negative of x minus 8, okay. So after we got the same factor, we can cancel out, and then we have this one. So after that, we can substitute x with 8. Okay. So substitute x with 8. Okay. So this time they show how we substitute x with 8. So we know here negative 1 below here. So 3 times 9. 9 is 3. Plus 3 plus 9. So here is 3 times 3 in bracket. So this one bracket actually. Okay. So this one bracket. So 3 plus 3. So means that 6 times 9. So we got negative 1 over 54. Okay. So that's actually happened. So if you don't understand, we can show the detailed solution like the one I show here, to make sure that you understand how we got negative 1 over 54. Okay class, so that's all for the video regarding using first principle to find differentiation. So don't forget, in the next video, we will discuss how to use the various rules of differentiation. So stay tuned for the next video. Bye bye.